Welcome to the lecture series of the Ordinary Level Mathematics Syllabus D.
This is our first lecture of the video series for Cambridge O-Level Mathematics.
Cambridge O-Level Mathematics consists of 8 main lessons.
First one, numbers, algebra and graphs, coordinate geometry, mensuration, trigonometry, probability, and statistics. Let's consider the first lesson, numbers. When you consider numbers, first we are going to learn about types of numbers. Under that, we have natural numbers. What are natural numbers? Natural numbers are the numbers that start from 1 and end at infinity. For example, 1, 2, 3, 4, 5, and so. These are called the counting numbers. All counting numbers are defined as natural numbers. Then the next one, integers. What are integers? Integer is a whole number that can be positive, negative, or zero. It can be the positive, a negative value, or zero. All the numbers are called integers, a whole number, not decimal places, but whole numbers. For example, -2, -1, and so on. And the main thing that these are not fractions. These cannot be fractions. Then the next one, prime numbers. When you consider prime numbers are the natural numbers that are divisible by 1 and itself only. Only 1 and the number itself. It is divisible only 1 and the number itself. It's better if you can keep in your mind the first 50 prime numbers, right? 2, 3, 5, 7, 11, 13, 17, 19, and so on. You can consider these all numbers cannot be divided by any other number other than 1 and itself. Consider 43. 43 is divisible by only 1 and 43 itself. Then you can clearly see 0 is not a prime number. Again, you can see that fractions are not prime numbers. Fractions cannot be prime numbers. The integers which are divisible by 1 and itself only, or natural numbers that are divisible by 1 and itself only. The next type of numbers we are going to learn is square numbers. What are square numbers? When a number is multiplied by itself, we call it a square number. For example, 1 times 1 is 1. So on 4, 9, 16, 25, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. For an instant, when you consider 3 times 3, this 3 times 3 can be written in the form of a square. 3 square is equal to 9. 3 square is also pronounced as 3 to the power 2. 3 to the power 2 means the base is 3. How many times it has been multiplied is defined as the power. The next type of number are cube numbers. When you consider a cube number, it is similar to a square number. A cube number is a result when a number has been multiplied by itself 3 times. Multiplied by itself 3 times. For an example, 8, 64, 216, and so on. 2 times 2 times 2 is equal to 8. 3 times 3 times 3 is equal to 64. 4 times 4 times 4 is equal to 116. For an instant, as previously, if you consider 4 times 4 times 4, again it can be pronounced as 4 cube is equal to 216. Earlier, the base was 3. Now the base is 4. It has been multiplied 3 times. So, 4 to the power 3. 4 to the power 3. The next part is common factors and multiples. When you consider common factors and multiples, mainly it is divided into two sections: the lowest common multiple and the highest common factor. Lowest common multiple is written as LCM and the highest common factor is written as HCF. But mainly for these two parts, there's a common path to follow. This common path is prime factors. Let's talk about prime factors. When you consider a prime factor, first you should keep in mind the prime numbers at least from 1 to 50. Let's consider an example for prime factors. They will give a question: express 60 as a product of prime factors. As I mentioned earlier, you should keep the prime numbers in your mind and divide the number which is given by the least prime number you know, or it can be multiplied. 60 is divisible by 2, divided by 2. 30. Again 30 you can divide by 2. 15. Again 15 can be divided by, can you divide by 2? No. It is not divisible by 2. So jump into the next prime number. The next prime number is 3. When you consider 3, 15 divided by 3 is 5. You cannot divide further by 3. So jump into the next. The next is 5. 5 divided by 5 is 1. Until you get the remainder as 1, you should follow the steps. That is how you will determine the product of the prime factors. Basically, the product of prime factors means you are writing the required value in multiples of prime numbers. Then we have divided now. You can take all the divisors together. When you take the divisors together, you should multiply each and every of the divisors to get the prime factors. 2 times 2 times 3 times 5. This is the prime factor. When you consider 2 and 2, 2 times 2 can be written as 2 square into 3 into 5. 2 square into 3 into 5. So you have expressed 60 as a product of the prime factors. We have talked about prime factors. Now let's consider the lowest common multiple, also known as LCM. You should follow the same steps as the prime factors for the numbers listed. For an example, find the LCM of 12 and 20. Divided by the least prime number that you know. 12 and 20 both are divisible by 2. You will get 6 and 10. Again it is divisible by 2, 3 and 5. But now you cannot divide 3 and 5 both by the same number. So the next prime number is 3. Divide 3 and 5 by 3. When you divide 3 by 3, it is 1. But can you divide 5 by 3? No, you cannot divide 5 by 3. If you cannot divide 5 by 3, leave it as it is. So 1, 5. Then jump into the next prime number, that is 5. 1 is not divisible by 5, so leave it as it is. 5 is divisible by 5, so 1. We have got the remainder as 1, 1. So, as previously, multiply all the divisors together to find the LCM. LCM is equal to 2 times 2 times 3 times 5, which is equal to 60. So, the LCM of 12 and 20 is 60. We have done an example to find out the LCM of two numbers. Let's consider three numbers. When you consider three numbers, find the LCM of 15, 12, and 18. Follow the same steps as previously and multiply the divisors together to get the answer for the LCM. Let's consider 15, 12, and 18. The first prime number you know is 2. But 15 is not divisible by 2. Leave 15 as it is and divide the others. 15, 6, and 9. Again, you can divide 6 by 2. Others are not divisible by 2, but still, you should go by the rules. 6 divisible by 2, 3, 9 not divisible by 2, so leave it as it is. Then we jump to the next prime number 3. Yes, 15 is divisible by 3, 5. 3 is divisible by 3, 1. 9 also divisible by 3. Again, you can divide it by 3. So, 3, 5 divided by 3, leave it as it is. 1 and 1 divided by 5. So, you will get 1 comma 1 comma 1. Then LCM is equal to 2 times 2 times 3 times 3 times 5. So eventually you will get the LCM as 180. 180. Now we have completed the lowest common multiple and the prime numbers. The next is a little different than these two. Some steps are the same, but a little different. Let's consider the highest common factor OHCF. We should follow the same steps as the LCM, but the steps should stop when there is no common divisor. When there is no common divisor, we should stop. Let's consider an example. For an example, you have find the HCF of 12 and 20. Follow the same steps. 12 and 20 divided by 2. You will get 6 and 10. Again divide by 2. You will get 3 and 5. The next prime number you are dividing is 3. But if you divide by 3, 3 is divisible by 3. Okay. But 5 is not divisible by 3. So there is no common divisor. You cannot divide 3 and 5 by a same value. No common divisor. So take the divisors until that point. That means 2 and 2. These are the values of the HCF. When you consider HCF of 12 and 20 is 2 times 2, which is 4. That is for 2 values. Let's consider 3 values. Find the HCF of 18, 20, and 30. Follow the same steps. Divide 18, 24, and 30 by 2. You will get 9, 12, and 15. 9, 12, and 15 all are divisible by 3. 9, 12, and 15 all are divisible by 3. You can divide by 2, but only 12 is divisible by 2 at this point. But in HCF, you should divide by the same common value, common divisor, 3. So 3, 4, and 5. 3, 4, and 5, there is no common divisor, so stop the steps. You should consider HCF as 2 and 3. So HCF is equal to 2 times 3, which is 6. Highest common factor of 18, 20, and 30 is 6. Let's move on to the next topic. Rational and irrational numbers. Considering rational numbers, what are rational numbers? A number that can be expressed in the form of a fraction. A rational number can be expressed as a fraction. Let's consider some examples. Half, -3, Nevertheless of the sign, you can consider it as a rational number. -3, 0, 5, 5.25. Exact decimals also can be expressed as rational numbers because exact decimals can be represented as fractions. 5.25 is 21 upon 4 and 0.3 recurring. 0.3 recurring means 0.33333. It is also represented as 1 upon 3. Some may assume as recurring decimals, not rational numbers. But recurring decimals, for an example, we have considered 0.3 recurring, 0.3333, and so on. 0.333 recurring can be represented as 1 upon 3. 1 upon 3 is a fraction, so it is a rational number. Then the next type of number is irrational number. When you consider an irrational number, it cannot be expressed in the form of a fraction. It is not possible to express an irrational number as a fraction. For example, root 2, the value of pi, and non-recurring decimals. These are non-repeating decimals or non-recurring decimals. Non-recurring decimals are considered as irrational numbers. Moving on, our last subtopic of the lesson, reciprocals. Considering reciprocals, very simple. Reciprocals are formed when we swap the numerator and a denominator. If you can remember what are numerators and denominators, let's recall. In a fraction, consider x over y. The number on top is called the numerator and the number in the bottom is called the denominator. So, when you swap x and y upside down, you can form a reciprocal. The reciprocal of 6 over 13 is 13 over 6. Just swap the top and the bottom. So half is 2 over 1. Another one, 15 over 23 can be represented as 23 over 15. It is called the reciprocal. Reciprocals are much more essential in our next lesson, fractions. So, see you in the next lesson, fractions. Thank you.